Okay, in this video we're going to go over the lesson 5.3 homework. So if you have done your notes and listened to them and done this homework, then this is a good review to make sure that your reasoning is just like my reasoning. So looking at this first problem, it says use the information in the diagram to find the answers. All right, so there's no equations that we have to work with, and each of these three questions is a little bit different. So the first question says find AD. So first you've got to realize what you have going on here. So what I'm seeing is that I have BD, so right here is BD. That is acting as an angled bisector. The reason why I can say that with certainty is because I see that this angle right here, so ABD, and this angle right here, which is DBC, those two angles are congruent. So that means that this ray BD must have cut that big angle ABC exactly in half. So once that happens, other good things start happening for us. So for example, D, which is right here, if I make a perpendicular line from D to C and from D to A, so I know it's perpendicular because I see these little boxes, what happens then is that the length of DC has to equal the length of AD. So therefore, AD will equal 7. All right? Okay, let's look at the next one. This time they want the measure of angle DBA. So that is this angle right here. So what's going on? I see I have an angle that's cut. Since these pieces are congruent and I have these right angles right here and here, what I know is that that big angle ABC was bisected. If it was bisected, the 20-degree angle below DBC is the same measure as the angle DBA because that's the other half. So that's 20 degrees. All right, so let's see what's going on for question 3. Now question 3 looks a little bit more complicated, so let's see what they're saying to us. So looking at question number 3, now it's my impression that they're missing one thing. So if I were to ask you this question, I would tell you one more thing. And that one more thing for me would be that this piece equals this piece. So if you have that, what do we have? Well, I know that if we have an angle bisector, then we're going to end up having isosceles triangles built right here. If that is the case, then we can say 10x plus 10 equals 8x plus 20. Subtract 8x, subtract 8x, that gives me 2x plus 10, okay, equals 20. Subtract 10, I have 2x equals 10, and therefore x equals 5. Okay, let's go on to the next problem, number 4, on the next page. Okay, number 4, what I'm seeing is that I have the perpendicular line here and here, a perpendicular box, and I have an equal line segment here and here. If those conditions hold, then I know that this ray right here that has no letters is going to be an angled bisector. Okay, because if it's an angled bisector, then if I take my stylus and I draw a point here, that point's on the angle bisector. If that is the case, then if I draw an angle, a line from the angle bisector to a side of the triangle, that will be congruent to this one over here, and right angles will form. So that's part of the angle bisector theorem. So once I establish that I have an angle bisector, then I'm allowed to set those two angles equal. Bisected means cut exactly in half. Now I'm just doing my two-step problem, and that's 4x equals 16. So divide both sides by 4, x equals 4. Okay, sometimes when you do these problems, instead of setting the two equal, you add them together. If you add them together, you have no place to go. So remember that they are equal to one another, so the operation connecting them is going to be an equal sign. All right, let's go on and do question 5 on the next page. In question 5 and 6, they're going to ask you if you can conclude that dA equals dC. So for dA to equal dC, that means that point D, which is right here, has to be on an angle bisector. That will only happen if these two angles are equal, which they are by the demarcation, and drawing a line from D to the edge of the angle, right here and right here, have to give me right angles. Once I see I have right angles and I have bisected angles, then, changing colors, then I know that this piece has to equal this piece. So you can say yes, since we've established that ray BD is an angle bisector. So go back, look at the angle bisector theorem and make sure that makes sense to you. All right, look at the next one. I see I have equal angles here. I do not know if angle A right here is a right angle. So I'm going to say 90 degrees, question mark. I don't know. Same thing here. Is this 90 degrees? Since they haven't told me, I cannot assume that it is. And since I can't assume it is, then I do not know if dA equals dC. So I would say no, need more information. And what information do you need? You need to know that DC is perpendicular to CB, and you also need to know that AD is perpendicular to AB. So that's the piece that you don't know. Okay, question 7, It says, can you conclude that BD, so BD is down the center, hopefully, bisects angle ABC? So what do I see? I see a right angle, and I see equal segments here. So yes, because of those two things, ray BD is indeed, I'll make that a D so it's a little bit clearer, ray BD is an angle bisector. And therefore, these two angles at the very top are the same. All right, we have one more question. We'll do that on the next page. Okay, in this last problem, they want me to be able to conclude that BE bisects ABC. So do I have enough information here to include that? And the answer is no. I have equal segments here and here. I would need a right angle here and a right angle here. So since I do not have that, so I'm going to say I'm going to need this. I need this, and I need that. Since I don't have that, I cannot say that it's an angle bisector. So I'm going to say no, cannot conclude that we have an angle bisector. What do we need? we need DC perpendicular to BC, and we also need DA perpendicular to BA. Okay, that concludes this assignment. Now, there's a little bit more material on this. We have not really talked about the in-center. So I'm going to do that with you when we meet again, but we need to go over something called the Pythagorean theorem before we can fully complete 5.4 or 5.3. So I'm going to do that now in another video.